So, welcome guys to this final session based on your number system. This is the practice session in which we are going to attempt some sums which are going to be based on everything that you have learned up till now. So, this will be the practice video. Remember, this is not the concept video, this is the practice video. So, I hope by now you have revised your concepts and you don't have any doubt in this chapter, and now you are ready to practice with me. So, I want you guys to start practicing if you haven't already. If you have, then I want you guys to just solve the sum first, then look for the solution with me. I want you guys to attempt each and every sum, no matter if you are able to solve that or you are unable to solve that, that does not matter. You have to attempt. That is the most important thing currently, because I know you guys won't be able to attempt each and get each and everything correct, but you should be attempting so that you guys know where you guys are standing among the crowd. So that will be the case here. So I want you guys to bring your pens and notebooks with you. So let's start with the video, and before I get to the point, let's just revise some concepts here. Just quick revision. So you guys remember what is number system, right? So that is the case here. Number system, it was divided into what? Groups. You had your types, which were real and imaginary. We weren't going to be focusing on this concept, so I just left it there. So I will be leaving it here also. This will be what? This is the case where those are numbers which cannot be represented on number line. So remember, any number which can be represented on number line, that will be what? That will be a real number, and those which are not able to be represented on number line, they will be your imaginary numbers. This is the concept of class 11, so we are not going to study it today. But real numbers were categorized into various groups: your naturals, your wholes, integers, rationals, and irrationals. Remember this, right? You guys remember these 5 groups, right? So this was the group which had numbers that could be beginning with a 1 and they go up to so on positive infinity. So that was the case. So any number which was lying in between these limits, that was a natural number. Wholes were what? They were the numbers which were beginning with a 0 and they were going up to so on infinity. So you guys see, every natural number and including a 0, that series will be what? That series will be a whole. And you guys remember what were integers? Those were your negatives and they were what? Including 0 and your positive. So if you had taken the mirror image of your natural numbers, those numbers will be negative and they will be what? They will be forming our integers if you put just 0 in the middle. So a number line which has 0 in the middle, positives will be on the right hand side of 0 and negatives will be on the left hand side of 0. That series will be of integers. So for every positive integer, you have a negative integer. Just considering the 0, this is the neutral integer. Now for the case of rationals, rationals are what? These were the numbers which were going to be represented in the form of p by q. I hope you guys remember by now everything that I'm going to tell you. So this is a quick revision here. So these were the numbers which were represented in the form of p by q, where q was not equal to 0. That was the main condition here, that q cannot be 0. And what were irrationals? Which cannot be represented in the form of p by q. So any cert, that means any integer or any rational number, or sorry, any natural number or integer which had a power in fractions, let's say 1 by 4, 2 raised to power 1 by 4, or 15 raised to power 2 by 3. These kind of certs will be what? They will be your irrational numbers. So remember, these are your irrationals. And you guys later understood the basic difference between your rationals and irrationals, right? So you guys remember, these were either terminating or non-terminating but repeating, right? They had their decimal expansion. Either terminating, that means they were giving me a remainder which was 0, or they were not giving me a remainder which was 0, but they were having decimal places repeating themselves. That means if I divide 1 with 3 or 1 by 3, I will be getting a 0.333, or you can say it will be what? 0.3 bar. Likewise, if you solve your irrational numbers, let's say square root 2, they will be having specifically non-terminating decimal expansion, but they will not be repeating. So they will be non-terminating and non-repeating. So if you guys remember a bit of this, you guys should be remembering that when I had long divided this to find out the square root, I had something like this. Let me just erase this. It was 1.14 and something that was going on, right? 414 and so on. So this was the case here. And the important thing here is that pi, which happens to be, we consider it to be 22 by 7, this value is in the form of p by q, it is rational, but pi itself is not rational because it is an infinite decimal. So pi itself is irrational, whereas this is rational because your pi is actually your ratio between your circumference and your diameter of the circle. So this is the relation here, that's why it is infinite. Then we had understood how to plot various points on number line. You could represent your rationals and irrationals. So those are the things which are practical, so I will be discussing while I have question in front of me, but these are some basic concepts that you have to remember. And then we had understood the concept of rationalization, right? The thing was, we had to rationalize our denominator in order to have a whole number or a natural number as our not whole number, actually natural number as our denominator. So that was the point here. We had to rationalize, let's say 1 over square root 2. I will be doing what? Just multiplying and dividing it with square root 2. I was having something like this, square root 2 over 2. This was what? A rationalized denominator of the irrational number. So these are some points here, and you guys also remember your exponents and powers. You had these rules, right? A raised to power m into a raised to power n, that was what? A raised to power m plus n. If you had a raised to power m divided by a raised to power n, that was a raised to power m minus n. If you had a raised to power m into b raised to power m, that means powers were same but bases were different. You had something like this, a and being multiplied together, and you had the common power m. Similarly, likewise, you had this a raised to power m divided by b raised to power m. You should be having something like this, a by b whole power m. And you had something also, a raised to power negative m. When the power was negative, we used to write it as inverse, so 1 over a raised to power m. So these were some basic concepts here, you guys should be remembering them. And one more thing, a raised to power 0, that was 1. So these were the major laws that we had understood and discussed in the concept of our exponents and powers, right? So I hope by now you are able to recall each and everything. So I am just going to keep up with the questions now. Try to keep up with me because I have 10 MCQs and later are your full length questions, and I want to complete this in entire one sitting. So this should be the case here. So let's just start with the video. Our very first question, we have what? Every rational number is a natural number, an integer, a real number, and a whole number. You guys remember I had specifically told you that if I have a natural number, let's say a 1, this can be represented in the form of p by q, 1 by 1, right? This is rational. So it is true for now. If I take any integer, let's say if I take negative 2, can this be written like this? Obviously it can. So this is also true. Now for the case of whole number, and by now you guys should be able to guess this one. But if I consider whole number, you guys see whole number is actually every natural number, but another it has a 0 with it. So that means, can I write 0 by 1? Obviously I can. It is also in the form of p by q. So that means all these three options are correct for this one. And you guys already remember the chart. Each of these three lies under your real numbers, right? Real numbers are your natural, whole, integers, rationals, and irrationals. So you guys can say the answer should be what? It should be real number because each of the other three is correct. So that means this would be the only option because each of the other three is lying under this. So that will be the case here. Now coming to our second question, we have this one. Between two rational numbers, there is no rational number, which is not true, right? We can find out as many rational numbers as we want. You guys remember that we had found out many rational numbers. I had told you one thing here. So there is exactly one rational number, which is also not true. I can find out as many rational numbers as I want. There are infinite many rational numbers. This can be true for the sake of argument here. Let's just put a dot over it. This can be true. Let's just check for our D option. There are only rational numbers and no irrational. Can this be the case? If you guys remember, I had told you, and we actually had performed this. We had found out irrationals between rationals also. Remember this case? 3 by 7, 8 by 11, I guess. Something was like this, right? Or 5 by 7 and 9 by 11, I guess. This was the case, and we had found out irrationals between those. So this cannot be the case. So there are infinite many rational numbers, but if there had been one more case that there had been infinite rational numbers and irrational numbers, so that have been the most accurate answer. But in this case, since we don't have that case, we just have only this, that there are only rational numbers and no irrational, which is not true because there are irrationals also. So our D option itself is wrong. So that means our C will be the answer. Now let's just see what do we have next. A third, decimal representation of a rational number cannot be. You guys should be answering me this one real quick. it can be terminating. Now the case is here, it cannot be. That means that the decimal representation that cannot be of an irrational, or sorry, if of a rational number. You guys see, they can be terminating, true. Non-terminating, they can be non-terminating, but they have to be repeating. The thing that they cannot be is non-terminating and non-repeating. So that means D option is correct. That means the only answer that represents an irrational number, or you can say that is not valid for the case of rationals, is that they cannot be non-terminating and non-repeating at the same time. They have to be either terminating or non-terminating but repeating. So that is the concept here for this question. Now let's move forward. Our fourth question. Product of any two irrational numbers is always. Now guys, see, if I take two irrational numbers, square root 2, and the options are always an irrational number, always a rational number, always an integer, sometimes rational, sometimes irrational. Now if you guys remember, I had explained this concept earlier in our conceptual videos. So you guys see, if I take examples here, let's say if I assume square root 2 and square root 2, and then I assume square root 2 and square root 3. So if I multiply these two, I will be getting a 2 here and I will be getting a square root 6 here. Now you guys see, 2 can be represented in the form of p by q, whereas root 6 is not. It is an irrational number. So your correct answer automatically becomes what? Sometimes it can be rational or sometimes it can be irrational, because both of the cases are right in front of your eyes, right? So if the irrational numbers are similar, then they will be giving you a rational. If they are different, then it will be giving you an irrational number. So that is the point here. I hope you guys remember this. But that is also not the case if I have something like this. Quad root 2 multiplied by quad root 2. Now guys, see, can I write it like this? 2 raised to power 1 by 4 into 2 raised to power 1 by 4. Bases are same, power will add, it will be what? 2 raised to power 1 by 4 plus 1 by 4. If you take LCM, that will be what? 1 by 2. So again it is what? A square root 2. So you guys see, if they are same, they again can be giving you an irrational also. So remember, the answer will be sometimes rational or sometimes irrational. That is the correct answer here. Let's just move forward with this. The decimal expansion of square root 2, what it can be? A finite decimal. See, it is an irrational, it cannot be terminating. Wrong. This is also terminating. Wrong. Non-terminating and recurring. You guys remember, this is an irrational number, it cannot be recurring. That means repeating. This is also wrong. So automatically your answer is what? Non-terminating and non-recurring. Or you could have just seen it here and you could have just ticked it here, because square root 2 is an irrational number. It will be having a non-terminating and non-recurring decimal expansion. I hope you guys understand this, right? Now let's just move forward with this. Which of the following is an irrational? You guys will be telling me this. So I hope you guys have found that one out. According to me, it should be C. Now let's just verify this one. I have a square root 4 by 9. If I just substitute the square root 4 over square root 9, this will be what? A 2 by 3, which is rational, so wrong. And in this case, square root 12 over square root 3. If I take square root on whole, 12 by 3, that will be what? Square root 4, which is what? 2. Again rational. And in this case, you can clearly see it is 9, which is rational. So our answer is what? Square root 7. So here I have just a bit thing here. If you have a square root on any prime number, it will always be an irrational number. Think of any prime number, put a square root over it, you will be having an irrational number. Example, square root 2, square root 3, square root 5, square root 7, and just an exception here, square root 6 also, because that is square root 2 into square root 3. So you guys see, that is same here. Square root 7, then you have square root 8, which is actually 2 square root 2. So remember, 2 is again prime number. So square root of any prime number is always irrational. That is the concept here. I hope you guys have understood the case, right? Now let's see what do we have in the 7th sum. It is this one. Which of the following is irrational? You guys see, terminating cannot be, repeating cannot be, repeating cannot be. Ultimately, this is the answer, right? Your bar represents the number are terminating. Oh, sorry, they are repeating. So here I did not have any bar and I did not have anything which was keeping on continuous. So you guys see, there should be dots here. Let's just assume there are. So this is terminating, it cannot be the case. This is having a bar over it. This cannot be the case because the numbers are repeating. Again, we have a bar over here, numbers are repeating. And in this case, you guys see 4001, 4001, 40001. Then this series will be continuous. There should be dots here. Otherwise, none of the answers will be correct. That is not the point here. This will be correct. Now let's see. What do we have next? 8th. A rational number between square root 2 and square root 3. We have to find out a rational number between this. Now you guys see how you are going to do this one. So you guys see, if I take our first option here, you guys see square root 2 plus square root 3 divided by 2. This is an irrational because I have two square roots here. Similarly, square root 2 into square root 3, that will be square root 6 by 2. Again irrational. So my answer should be one of these two. For that, I have to check which one is correct. For this, I am just going to assume square root 2 is what? It is 1.414 and something after this. I am not going to consider that one, I am going to consider this one. And square root 3 is what? It is 1.7 something, right? Now you guys see, I have to find a rational number. So you guys see, I have 1.5 and I have 1.8 here. So 1.8 cannot be the case because it is crossing this limit, right? 1.7 and there should be something more after this, 732, right? So this is crossing that, so it cannot be the case. So your answer is what? 1.5. So that is the answer here. I hope you guys have understood the case, right? Now let's just move on with this and see. We have this one. So value of 1.999 in the form of P by Q, where Q and P are integers. So if I tell you the trick here, remember this trick. See, this number is first of all non-terminating. So this cannot be the case. This cannot be the case. So answer should be one of these two. Now, if you guys remember the exercise question from your NCERT, it was this, right? 0.999 dot dot dot. It was closest to what? It was closest to your 1. So its answer was what? It was 1. Similarly, if I have 1.999 and if I just assume this, you guys see it is more than 1 and it is nearest to 2. So answer should be what? It should be 2. Now, the calculation point is totally on you. You can just solve this one, assume this one to be your x. You can use the traditional method and you can find out. But the answer will be 2 because this value is very near to your 2. So it has to be 2. It cannot be this. If I just tell you one more trick here, this will be what? A 0.111. You can see here. So this is less than 1. Our answer is more than 1. So it has to be 2. So it is the only answer. I don't even have to use the traditional method. So I hope you guys have understood the case. Now let's see what do we have in the 10th part. So answer of this, you guys see 2 square root 3 plus square root 3. You guys see, if I assume square root 3 to be x, I have what? 2x plus x, that will be what? 3x, or you can say 3 square root 3. So I hope you guys, this is easy, right? You guys should be able to solve this one. So these were your 10 MCQ questions. I hope you guys were able to attempt and get each and every question correct. Now I'm going to move forward with this. So let's just start with the very short questions here. These are very short. Let x and y be rationals and irrationals respectively. Is x plus y necessarily an irrational number? Give explanation to support your answer. Now, see, I have been given, I have two numbers, x and y, x being rational and y being irrational. So, I have to check whether rational plus irrational is always what? Is necessarily an irrational or rational. For this, I am going to assume x to be, let's say, 2 and y to be, let's say, square root 2. Right, both of them satisfy the given condition. So I have to add x and y. So 2 plus square root 2. You guys see, this is what? This is irrational, obviously. But see, they had asked to give an example to support your answer. So this is the answer. This is an example here. You can support the answer here. You can assume this one to be rational. Let's say it is rational. It can be represented in the form of p by q. Okay, let's just say it can. So I'm going to do what? I'm going to square both sides here. Square here, square here. This will be what? A plus b whole square, that should be a square, plus b square, that means square of square root 2. That means it will be what? A 2, right? Square root 2 whole square, that is 2. And 2ab, that means 2 into square root 2. That will be what? 4 square root 2 equals to, that will be what? P square by q square. Right? That is the whole point here. Now you guys see, if I just start to substitute every value on the other side. So 4 square root 2 here, keeping it here, p square over q square minus 6. Then if I substitute this, I have what? Square root 2, which is equal to what? P square minus 6q square, considering LCM here, divided by q square and a 4 here, that should be in multiplication. Now you guys see, every value is in square here. If you can see here, P has a square over it, Q has a square over it, and even denominator has a square over it. So you guys see, none of the values after being squared will be giving you any square root. So that means our assumption is wrong here, because square root 2 is an irrational, but according to the given statement, it is rational. So this cannot be the point here, and you guys have assumed it wrong. So that means it is indeed an irrational number. So I hope you guys were able to get this one, right? See, if you have to support your answer, you have to just do what? Square both sides. You are going to learn this concept in class 10 also. You will be having this concept in your class 10 also. So it is better to learn by now. See, if you have to support this one, you have to do what? You have to just square both sides. So this will be the case here, right? Now let's just see what we have in the second question. It is this one. Let x be rational and y be irrational. Is xy necessarily an irrational? Justify with an example. See, this condition holds if x is not equal to 0. Remember, 0 by 1 is a rational number. But if x is not equal to 0, then xy will always be irrational, provided y is, let's say, an irrational number square root 2. So guys, see, if I assume x to be 1 and y to be square root 2, it will be what? Square root 2. If I assume x to be 2 and y to be square root 5, it will again be 2 square root 5. But once I have assumed x to be 0, my answer will end up being 0, which will be what? A rational. So you guys see, it is not necessary that xy will be irrational if x is being rational and y being irrational. This holds only, see, xy will be irrational if and only if x is not equal to 0. This is the condition here. If x ends up being 0, then your whole answer will become 0. And 0, you guys know, that is rational. So this will only hold if your x is not equal to 0. For any value other than 0, if you put it as your value of x, you will be getting the answer, it will be irrational. That is your homework. Assume any value, just put it here, you will be getting an irrational number. So if x ends up being 0, that will be 0 and that will be rational. So only condition is here that x cannot be 0 anywhere. So that is the whole point. I hope you guys understand this, right? Now let's just see our third question. So these are just true, false. You guys should be able to solve them. We have what? Square root 2 by 3 is a rational number. False. Quick. Because we have a square root 2 here. This is false. This is an irrational number. There are infinite many integers between two integers. Can this be the case? Can you have infinite many integers? If I have 2 and 3, there can be what? Decimals, right? 2.1, 2.2, 2.3. These are your rationals but not integers. This is false, right? You will be having decimal values. You cannot have whole, your mirror images of your whole, your natural numbers. That cannot be the point here. Number of rational numbers between 15 and 18 is finite. See, you can have as many rational numbers as you want between any two given numbers. So this will be false here, because this has to be true. There has to be infinite numbers. There are numbers which cannot be written in the form of p by q when q is not equals to 0. So this can be true, because you guys remember, if I take a square root 2, this is also part of numbers. It cannot be represented in the form of p by q, and there are infinite many numbers, and some of them might be able to be represented in the form of p by q, and some might not be. So that is the whole point here. So they will not be able to be represented in the form of p by q, given if they are what? Irrational numbers, right? You guys remember this. Now let's just see, if I just move on with this, and I have this one. Square of an irrational number is always rational. Can this be true? Think of this. If I have, let's say, a square root 2, if I square this, I will be getting a 2. But what if I have something like this, a quad root of 2, sorry, not square, actually quad root. If I have quad root of 2, that means I am square rooting it twice. Will squaring it be mattering much? You guys see, this will be what? 2 raised to power 1 by 4, its whole power 2. They will be cancelling out, and yet you will be getting what? A square root 2. So it necessarily does not mean if you have any irrational number and you end up squaring it, it will be giving you a rational or an irrational. There is no surety that it will always be rational or an irrational. Given if you have a square root, then it will be giving you a rational. If it has any other root which is not square root, then it can never be rational. It will be irrational always. So that is the whole point here. I hope you guys understand this, right? If you take cube root of 2, if you don't go any far, if you square this one, you will be having what? 2 raised to power 2 by 3. Again, it will not be your rational. Now, in this case, you have already solved this one. This will be giving you a rational. And now you guys see, is not a rational number between this one. So, you have to verify this one. Just square, this will be what? Let's just see. 12 is actually what? It is 4 into 3 and a square root over it. You guys see, square root of 4 will be 2 and there will be 2 square root 3 and there is a square root 3. And you guys see, if you solve this one, you get what? You get a 2, right? 12 over 3, that is square root 4, that is 2. So you guys see, if I just solve this one, the value is what? 1.732 and this will be what? 2 into 1.732. So you guys see, your value is what? Let's just see, 4, 6, 14 and this will be what? A 3. 3.464 and 1.732. 2 will be lying in the middle. So this is a rational number between these two. So this is what? This is false again, right? 15 by root 3 is written in the form of p by q. So it is a rational number. Can this be the case? Let's see. Square root 15 over square root 3. If I just put square root over both, so 15 by 3, this will be what? A square root 5, which is irrational. So again, this is what? This is false. I hope you guys have understood the case and you don't have any doubt in this, right? Now let's see, what do we have in a question 3? Actually next part, question 4. So we have to classify the following as rationals or irrationals. You can easily do this one, right? This will be 14. This will be what? 2 into 9 and a square root over this. This will be what? Square root 2 into 3 into 3. That will be what? 9 root 2. This is what? Irrational. So you can easily solve these. Just note them down after you have watched this video. You can just pause the video here, attempt each and every question, then continue with the video. That is the whole point here, because you have to find out, you have to check whether the numbers are rationals or irrationals. This is quite easy. Any of you can do it. So I hope you guys will be able to solve this one, right? So I'm leaving this question on you. Let's just move forward. So these are your short type questions. We have what? Find which of the variables x, y, z and u represent a rational number and which represent irrational. So you guys see, we have to find out which will be rationals and which will be irrational. Quite easy. We have x square which is equal to 5. X will be what? Positive and negative square root 5. But you have what? You have a square root over here which is irrational. So this will be irrational. Now in this case you have what? Y square equals to 9. Y will be what? Positive and negative 3. This will be what? Rational. Now in next case you have z square which is equal to what? 0.04. If you remove its 0, you will be having 100. Then you do what? Square root. So 4 over 100. This will be what? 2 by 10, which will be what? A 0.2. If you do, or you can just leave it here. See, this is rational. Now in this case you have what? U square is equal to 17 by 4. U will be what? Square root of 17 by 4. No, square root of 17. 17 is prime number. It will be irrational. And square root of 4 will be what? It will be 2. So this is what? This is irrational. So I hope you guys were able to get each and everything correct here, right? You don't have any doubt in this, right? So that was the case here. Now let's just move forward. We have to find out 3 rational numbers between these. So I'm going to attempt any of 2 here. You're going to attempt the remaining 2 yourself. That will be your work. So if you have done the previous question, now you're watching it here. So pause the video here while I've done the 2 questions and attempt every question on your own. So see, firstly, I'm going to attempt this one and I'm going to attempt your 4th one. So you guys see I have what? -1 and -2. Now, you have various methods to find out rational numbers. You can even use your averages, or you can make the denominator same, then multiply with the common factor. That can also happen. So I will be following the second method, not the average one. So I already though know the denominators are same. It is 1 and 1 here, right? So I have to find out 3 rational numbers. So I will be thinking of any number which is greater than 3. Let's say I think of a 10. So multiplying this with 10, dividing this with 10, multiplying this with 10, dividing this with 10. So my limit is what? -10 by 10 and -20 by 10. Now you can write any 3 numbers. -11 by 10, -12 by 10, -13 by 10. Right? That is the case here. Or you could have done it like this. -1, -2. In between you will be having a -1.1. Right? Let me just erase this. In between these two you will be having a -1.1, -1.2, -1.3. Remove the decimals. These will be your rational numbers. Right? So easy. Now for the fourth part, you have what? Let's see. It is this one, 1 by 4 and 1 by 5. Firstly, do what? Make the denominator same. So for that, I will be taking LCM, or you can do what? Just multiply this with, let's just take their LCMs first. So their LCM will be what? 4 and 5, it will be 20. Think of any multiple of 20, or you can do what? Just let's just take LCM first. So it will be 20 here. You will be having what? A 5 and a 4, right? Now think of any number which is greater than 3. I'm going to think of a 10 again. So multiply this with 10, multiply this with 10, and multiply this with 10. The reason I'm multiplying thrice is because I can write it like this: 5 by 20 multiplying this with 10 and dividing this with 10, and 4 by 20 multiplying this with 10 and dividing this with 10. I'm just taking LCM, so it does not matter whether I'm going to multiply them here like this or like this, because LCM will be 200. So choice is yours. Either you can do it like this or you can do it like this. So my limit is what? 40 to 50, write any three. 41 by 200, 42 by 200, 43 by 200, and so on. You can write as many as you want. So that is the point here, right? So I hope you guys will be able to solve the remaining two questions here, right? That is your homework. Now let's just move forward with this. We have this one. Insert a rational and an irrational. So you guys see I have 10 parts here. I will be again attempting 3 or 4 parts. Remaining will be your work. So we have to insert a rational and an irrational. So remember this, a rational and an irrational. Difference according to your decimal expansion is what? Rational is either terminating or non-terminating but repeating, right? And for the case of your irrationals, they are what? Non-terminating and non-repeating. So that is the whole point here. You have to insert a rational between this. That will be easy. 2 and 3, you guys see there will be infinite decimals here. So I can write it like this. 2.1 divided by 10. That will be what? 21 by 10. That is one rational between this. Now I have to write an irrational. So listen carefully or look here carefully. 2 and 3. My final limits are 2 and 3. Let's just think of a number 2.01, 001, 0001, 00001, and so on. This is what? This is an irrational. You guys see none of the digits are repeating as at a regular interval. Their digits are changing, their intervals are changing. So this is what? This is an irrational, and this is what? A rational. Easy, right? You can attempt any of these on your own, right? I hope you guys are able to do that one. So I'm going to attempt this fourth one for you. I have this one, minus 2 by 5 and minus 1 by 2. So you have a choice here. I'm going to do what? Because they have their denominators in the form of 5 and 2, they are what? They are terminating. So this will be what? Minus 0.4, and this will be what? Minus 0.5. So my limit is this. I have to write one rational and one irrational. This will be what? 41 over 100, right? This will be 0.41. That can happen here, right? I'm doing just simple division here. So this will be what? A 0.4, and this will be a 0.5. Negative both. So you can put it here. Negative 0.41. This will be what? 41 over 100. Now I have to insert an irrational. That can happen like this. Negative 0.41, 441, 4441. Or you can just do it like this. So this will be an irrational, this will be a rational. I hope you guys are able to solve this one, right? That is the whole point here. Now for the sixth question, let's just look at this one. Our sixth, we have square root 2 and square root 3. Square root 2, square root 3. You guys know the limit, it will be what? Let's just assume its first 3 decimal places. It will be what? 414, right? And for this case, 1.732. You guys see my limit is this. There are many more digits here, but I'm going to consider these 3. So one irrational, that would be what? That would be this 1.42, or you can say 142 over 100. Easy. Now I have to think of an irrational. So irrational will be what? And it can be this 1.42, 442, 4442, and so on. Right? That can be the case here. So I hope you guys are able to solve this one and you don't have any doubt in this, right? That is the whole point here. Clear? Now, remaining, I guess you are going to attempt on your own. They are very easy. So you can attempt each and every of the remaining on your own. You can ask me in the doubt session. I will be happy to clear your doubts. But I want you guys to attempt each and everything on your own now. So this will be whole point here. I have attempted the questions which are, I think, typical for you guys. So you guys know, you guys get an idea here what you are going to do. So attempt that on your own. So these two are your terminating. You can write any rational number here and one irrational here. So that is the whole point, right? Let's just move forward with this. So represent the following on number line. You have to represent them on number line. Quite easy. Let's just pick with this one. I'm going to pick this one. So guys, see, either you can do what, represent each and everything on the same number line, or you can do what, you can just represent separately. How you're going to represent on the same number line? Just do what, write the statements here. 7, 7.2, minus 3 by 2, and a minus 12 by 5. Do what? Just have their common denominators. So I know if I take LCM, this will be what? 70 by 10. Right? That will be the case here. This will be 72 by 10. This will be, if you guys want to solve this one, you can solve this. This will be what? Minus, if I multiply this with 5 and divide this with 5, this will be minus 15 by 10. And this will be what? Minus 24 by 10. So now you have to do what? You have to draw a number line. You have to assume an interval of 10 like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This will be a 1, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This will be a 2, and so on. These are your negatives because we are going on the left hand side. So you can easily represent any you want. Since I want to represent negative 15 by 10, so you guys see that will be the case here. This is minus 10 by 10, 11 by 10, 12, 13, 14, and this will be what? Minus 15 by 10. I got it here. Now for minus 24 by 10, this is minus 20 by 10 here, right? So this will be what? 21 by 10, 22, 23, and this will be what? Negative 24 by 10. Then you have to look for these. That will be quite lengthy here. These two are negative, so it will be here. These two are positive. They will be lying on the right hand side. So I hope you guys will be able to plot them, right? Easy. Or you can do what? You can draw separate number lines and you can easily represent them on number line. That will be the case here. You can either attempt to represent them on the same number line, or you can represent on the other number line. That is not the point here. You are able to understand the base concept. I guess you are able to understand that, right? So you can draw 4 different number lines, or you can represent on the same one. I just wanted to tell you that you can represent on the same one. So I just wanted to tell you this method. That's why I chose to have only one number line, but that is totally up to you. You can draw 4 ones. That is your choice, right? I hope you guys are able to understand this, right? Now let's just see if I just continue with the 5th one. So these are the very important questions here. You guys already remember how we are going to plot this one. So for the sake of argument, I'm going to do what? I'm going to assume this square root 17. So you guys see, square root 17 is what? For this, firstly, you remember we have to use Pythagoras theorem, right? So h is equal to what? Square root p square plus b square. So I have to represent root 17 in the form of this. So can I write root 17 like this? 16 plus 1, where 16 is what? A square of 4, and 1 is what? A square of 1. So I have my perpendicular, which is 4, I have my base, which is 1, or you can interchange this, or you can say I have my base, which is 4, I have perpendicular, which is 1. So you have to do what? You have to draw a number line. Let's say this is my number line, and I'm going to just draw it a little bit downwards. Let's say this is my number line. I'm going to have a base of 4 centimeter. Let's say this is my starting point, and let's say this is the 4th point here. This is my base. Considering either this one as my point or considering this one as my base, I will be constructing what? A right angle triangle here. See, the thing, I chose this one or that one because you guys see, if I just draw perpendiculars on these both points, I will end up getting a rectangle. And you guys remember, diagonals of rectangle are equal. So it does not matter whether you are going to measure the diagonal here or you are going to measure the diagonal here, because the length will be same and your answer will always be, you will always be having the answer by putting the length of the, by having the compass of the arc as your hypotenuse and putting it here, marking the arc here. That is the whole point. So choice is yours. Either you can consider this one as your starting point and you can just draw perpendicular here, or you can just construct the perpendicular here, because you will be ending up getting a rectangle. So it does not matter which point you are choosing, but you just have to be careful while plotting that distance. You have to always assume your origin or your 0 as the base point. So for sake of argument, I'm going to consider this one as my base. I will be drawing a right angle triangle, I will be constructing a right angle here. You guys already know how to construct right angle, so that should be the case here. This will be the point here. Then I have to consider, since my base is 4 and my perpendicular is 1, so I will be having my compass of an arc 1 centimeter. I will be putting it here, marking an arc here. Let's say this is the point, joining that one, then putting the compass here, opening an arc of this much length, putting it here and marking it here. So my point should be lying somewhere here. So this will be what? This will be a square root 70. So this is how you are going to represent your points. You can easily represent this one and you can easily represent that one. So that is the whole point here. And these can easily be done by you. So I will be leaving it on you. You have to attempt the remaining two. Now I have one more question for you guys, which is this one. We have to represent now these values, these irrational numbers. Now if you compare these two, you guys see you had natural numbers in square roots, right? But here you have what? You have decimals, so you can say your rationals in square root. So how you are going to represent this one? So for this, listen carefully, watch observely. You have to watch carefully on this. So you guys see, for this method, firstly you have to do what? You have to just draw a number line. Let's just draw it. Okay. Then do what? This is your starting point O. Whatever the value is in square root, mark the distance of that much length. So I will be marking a point at a distance of 4.5 centimeter from the origin. Let's say this is the point B, which is 4.5 centimeter from origin. Okay. Then you have to do what? You have to mark another point exactly at a distance of 1 centimeter. Let's say this is the point C, exactly at a distance of 1 centimeter. Okay. Now you have to do what? Now you have to draw the perpendicular bisector of this. You guys remember perpendicular bisectors, right? We have a straight line, we have to draw a perpendicular bisector. What we do? We just put compass on either of the 2 points, open up the compass to more than half of the length of line. Let's say this much distance. Then do what? Put the compass here, mark a point here. Let's say that is the arc here. Put the compass on point C, mark an arc here. Let's say this is the point. Similarly, same here, this arc, and from there that arc, join these two. So this is the perpendicular bisector of the line. Again, open up the compass to more than half of the length of line. Let's say from till this point, put the compass here, draw an arc here, put the compass on the C point, draw an arc here. Similarly on the other side, join the both sides. This is perpendicular bisector. There is one more way, but that won't give you bisected line. So you have to draw the bisector also. So if you guys see, the distance from here till here and distance from here till here, that will be exactly same. That is the whole point of perpendicular bisectors. Now you have to do what? Just name this point. Let's say this is point A. Put the compass here for the last time. Open up the compass to this much length, considering this as your radius. Draw a semicircle. So your semicircle should be like this. Okay, this is your semicircle. Now you have to do what? You have to now go back to the point B, draw a right angle here. Right, this is the right angle. Let it intersect the circle at any point. Let's say this is point D. Join that point with what? Your O. Or you can join with A. Join this one. Then do what? This extended line will be what? This point will be your square root 4.5. I hope you guys understand this. So this extended line will be your square root 4.5. I hope you guys understand this and you don't have any doubt in this. You can easily solve this one. That is quite easy for you guys. I hope you don't have any doubt in this. Or you can do what? You can just put the compass here, mark this length and just draw an arc here. Don't just use A. Do what? Just use your B point. Put the compass here on B. Open up the compass of this much length. Draw a quadrant here. Wherever it reaches, that point will be a square root 4.5. Similarly, you can attempt this one, you can attempt this one, and you can attempt that one. So I hope you guys will be able to solve these, right? So this will be it. And so we have to represent these in the form of P by Q. These are easy, you can easily attempt them. So I will be attempting, I have 6 here, right? So I will be doing any 3. So for the first one, 0.2, this will be 2 by 10, or you can say 1 by 5. That was terminating. Now for the second part, we have what? 0.888 dot dot dot. So let us assume let x equals to 0.8 bar. Now since only one decimal digit is repeating, I will be having 1 0 after 1, sorry, so that will be what? That will be your 10. I have to multiply this with what? A 10. So marking this my first, multiply 1 by 10. So I have what? A 10x, which will be equal to what? 8.888 and so on, which can be written like this: 8 plus 0.888 and so on. So this will be what? This will be 10x equals to 8, and this value is what? This value is x. So 8 plus x, so it will be what? 9x equals to 8. X will be what? 8 by 9. That is the answer. I hope you guys understand this. So that is the answer here, right? Similarly, if I attempt the sixth question here, we have what? We have this 0.134 bar over 34. That means it is like this: 0.1343434 and so on, right? These are like this. So you guys see, 1 is not repeating but 34 is repeating. So I have to take 1 out also, and I have to take 34 out also. So that means I have to multiply this with what? 1000. So let us assume x, which is equal to 0.1343434. Mark this here first, multiply by 1000. So you have what? 1000x, which is equal to what? 134.343434, right? That is the case here. Now I have to do what? Just subtract these two. So x equals to 0.1. That will be a different case here. Let me just, yeah, we cannot do it like this because the answer will be different. So firstly we have to do what? Let's just try the different method here. Let me just erase this and start over with this. See, we had this one 0.134. that method will not be applicable. So we will be doing this in 2 steps. So you guys see, first step will be what? I will be taking this 1 out only. So I will be having this one equal to x, multiply 1 with 10. The reason why I am doing this one, I will be explaining. Just observe this one. I will be multiplying this with 10. This will be what? A 10x, which will be equal to what? 1.343434. Now if you had observed our previous point here, we had this one 134.343434 and so on, and while I was subtracting that, I was having this 0.1343434. and you guys observe carefully, 43 and 34, they will not be subtracting. I will again be having an answer which will be non-repeat, actually non-terminating but repeating. So in order to remove that, I have to put 34 under 34, right? So for this I have to take this one out. That should be here, this one should be here, and then everything will be same. So you guys see, while I multiplied this with 10, my whole equation will be looking like this. If I just subtract now, it will be like this: 1.343434 and so on. You guys see, this will be cancelling out, and ultimately I will be having the answer. So reason here is that while I multiply that with 1000, I surely be getting this one, but I need to have what? I need to subtract the non-terminating part. I need to eliminate that one. For that one, I have to observe the same value should be lying under same, only then they will be cancelling out. So that is the whole point here. There is one more way around this one, but that will be quite typical for you guys. I can explain that one. So let's see, if we have time, I will be explaining that one. But for now, if this is the case, I'm going to assume this one as my second. And again, in order to get this value, I will be doing what? Multiplying 1 with 1000. So I will be having this 1000x, which should be equal to what? 134.343434. I will be doing what? Subtracting these two. So 10x here, which should be equal to 1.343434. This will be cancelling out. I will be having what? 133, which should be equal to what? 990x. X will be what? 133 over 990. That will be your answer. There can be one more way, but for that we should not be multiplying that with 1000. Instead, we will be multiplying with 100. So that will be whole point here. If you multiply that with 100, you will be having this 100x, which should be equal to what? It should be equal to 13.434343 and so on. And if you solve this one, just subtract x from it, you will be having this one 0.1343434. So you guys see, this will be cancelling out. You will be having what? 13.3, which should be equal to 99x. X will be what? 133 over 990. So there are various ways you can attempt each and every question. You can even attempt that one. This will be easier if you guys understand this. That is the point. And I guess your session is getting quite lengthy and I have various questions here. So I think it would be better if we have one more session in which we are going to complete the remaining questions. I guess they will be taking quite a long time. So I hope, let's just see 5 more minutes. What can we do with that one? So these are some questions. You have to simplify them. We have what? A square root 45, and this is actually 3 into square root 20, and this is 4 square root 5. So we have to solve this one. If you solve this, you have what? Let's see. Square root 45. Can you write it like this? 9 into 5, right? And can you write 9 like this? 3 into 3 into 5. This is a square. It will be 3 root 5, right? And this is 3 into square root 20, right? Can you write it like this? 3 into 4 into 5, which can be written like this. 3 into 2 square root 2 into 2 into 5. This is again square. That will be what? 3 into 2 square root 5, which will be what? 6 square root 5. And ultimately you have what? 4 square root 5. So it is actually 4 square root. If I put each and every value here, I have what? 3 square root 5 minus 6 square root 5 plus 4 square root 5. Now guys, see, each of them is sharing the same irrational portion, so their coefficients can add and subtract. So 3 plus 4, that will be 7. 7 minus 6, that will be 1. So your answer is what? Only square root 5. That is the answer. I hope you guys understand this, right? So that is the answer here. Now, if I just repeat this, if you want me to. So square root 45 is what? 9 into 5. This can be written like 3 square root 5. And this is 3 into square root 20. This can be written like this, 6 square root 5. 4 square root 5 was as it is. Then you have to just add and subtract. If you're getting confused here, just assume square root 5 to be x. Then your whole equation is like this. 3x minus 6x plus 4x. You can easily solve that one. So you will be getting what? You will be getting an x, right? Now you have the second question. Let's see what do we have with this. We have this one. Square root 24 by 8 plus square root 54 by 9. So you guys see square root 24. Can this be written like this? 6 into 4 by 8. And square root 54. Can this be written like this? 9 into 6, right? Divided by 9. So you guys see square, this is square. This will be what? 2 square root 6 by 8. This is again square. This will be what? 3 square root 6 by 9. This will be what? A 1 by 4. This will be a 1 by 3. Take LCM. That will be 12. 3 square root 6 plus 4 square root 6. So your answer is what? 7 square root 6 by 12. That is the whole point here, right? This is how you are going to attempt this one. I hope you don't have any doubt in this. So this is how you are going to attempt each and every question. And let's just, these two will be your homework. How you are going to do this one? Just correct the statement. It will be this: 4 square root 12 into 7 square root 6. You guys can easily solve this one. And remember, this is divide here. This is divide. So we have this one: 4 square root 28 divided by 3 square root 7 divided by 3 square root 7. So this is the whole case. Actually, this should be plus here. This will be plus. Or let's just not complicate this one. Let's just assume this is positive also. So this is positive, this is positive, this is positive again. So you guys see 3 square root 7, 3 square root 7. This will be 6 square root 7. This will be what? 4 into 4 into 7, right? 28 can be written like this. This is again square. This will be what? 4 into 2 square root 7 plus 6 square root 7. This will be what? 8 and 6, 14 square root 7. So this is how you're going to attempt this one. So I'm just going to leave the video here. I have some more questions. I will be having one last session. Since this session is getting quite lengthy, I don't want to bore you guys. So practice till here. Rewind the video and watch it again if you have to. practice each and every sum on your own. I'll see you in the second part. That means that will be the last part. So I'm going to end the video here. See you then. Practice till then. Okay.